Welcome back. We are still on chapter 2, data visualization, the second chapter in Barry Cohen's Explaining Psychological Statistics textbook for our Education Psychology 6600 class. But this video is not going to be about the slides about the content of the chapter as much as it's going to be on how to apply these concepts of plotting data and using the examples Eno's data set. Now in chapter 1, we took Eno's data set and using the data dictionary that we found in Appendix C, we read in the data from an Excel data set, we renamed all the variables to lowercase, and we applied factor labels to declared factors in the data set. And when we took our variable gender, which was the numbers 1 and 2, as a number variable, numeric variable, and applied the labels so that 1 was female and 2 was male, we renamed that as factor F. The capital F at the end of the name tells us that it's the factor version that has the labels applied. And so it will, if we use the gender variable, we will only have the 1s and 2s, and the variable will be treated as a continuous number. Whereas if we use the gender F variable, it will use the category labels and treat it as a categorical variable. So that was chapter 1. We read in the data and wrangled it. So now I'm going to show you how you can make those frequency tables. Now I told you back in chapter 1 that those doing the wrangling, especially the factor labels, that was the most typing we would pretty much do most of the semester. So here, as promised, now I have saved my outputted data set here to data clean. I think in some of the homeworks we call it Eno clean. As long as you're using the right name of your data set, it should work the same in your data, in your R Studio. Once we have that clean data frame saved and we run the cleaning and wrangling so it's in the global environment, we can call that data set up in any code chunk. So I can use the data set, and we're almost always going to start with the data set for all of our pipelines. We're going to take a data set and we're going to pipe it into a function. Again, we're taking the object and doing a verb to it. So here we're going to take the clean data set, which we've called data_clean, and we are going to link it or pipe it into a function called table F in the furniture package. Now to use this, before we only did loading the library tidyverse and loading the readxl package, but now we're also going to have at the top of our file loading the library furniture. Now tidyverse and readxl are from our studio with Hadley Wickham. They're anytime you Google, you're gonna pretty much see these packages. The furniture package was actually developed here at Utah State by Dr. Tyson Barrett, and he is a colleague of mine, and he and I have developed this course together. He called it the furniture table because he has lots of table making functions in it. And we are going to use table 1 and table F and table X, several of them. He also has a function in there he calls washer. It has, I don't think he's kept up with it, but that's where the name furniture came from. So we're going to use the furniture package, and then double colon says in the furniture package, use the function table F. So table F is a verb that's going to take the inputted data set and make a frequency table. Table F, the F is for frequency, for factors. And we're going to tell it which variable, and you only can do one at a time, which variable we want to make the frequency table of. So if I want to do a frequency table of the major variable, I'm going to use the major F version of the variable so that I have the labels. That's a lot easier to read instead of if I'd use the major without the F variable, then it would just label them major 1, 2, 3, 4, 5. And we'd have to keep flipping back and saying which was number 1, what was number 2. Because we applied the factor labels to the variable called major F, when we do data clean, so take the data clean data set, always start with the data set, pipe it in to the furniture packages function table F for the major F, table F for the major F variable. we will get this table. Now, if you run this code, you will get this table. So we can see in our data set, we have 29 psychology majors, 25 pre-med students, 21 biology students, 15 sociology students, and 10 economics students, for a grand total of 100 students. Eno's data set has 100 undergraduate students in it. And so if I wanted to know about the distribution, using this table, you could say that the most common major was psychology with 29%. Now, because it's out of 100, the percentages and the counts are the same number, but it's usually not the case. So I can do this same code. I can copy and paste it and just change out the variable that I make the table for. So this is doing a frequency table for the major, but I could also do it for another variable like phobia. Now for major, there were only 5 majors, but for phobia, they had each of the students on a scale of 0 to 10 rank how math phobic they were. You can think about what score you would mark. And so 0 was not math phobic at all. And the max 10 was so extremely math phobic, I want to vomit. I think it said something like that. And so we have the frequencies, cumulative frequencies, percentage, and cumulative percentages. So when I take the time right here, major had 5 levels. What kind of variable is that? There are 5 possibilities. 5 possibilities only, one the other, but not overlapping, because we're not doing double majors. That's a nominal variable because there's no implied structured order to those majors. Phobia definitely has order, and we could treat it as an ordinal variable, or we could treat it as a continuous variable. And this is an argument that social sciences have a lot of the time, have an argument that they discuss lots of times, because we can't have a score of 1.3. And really, do we know for sure that the difference between 2 and 3, that gap, is the same size gap as 7 and 8? We've applied numbers here, but is it truly interval ratio? It's a Likert scale, where a Likert scale is ordinal, where we attach numbers. What if I attach the numbers 0, 5, 10, 100, 700, or something like that? Why did we use consecutive digits? Usually a single Likert item should be considered ordinal, but the exceptions that have been kind of agreed upon in social sciences is if there are more than 5, some people say 7, some people say 10 levels, you can treat it as if it's continuous. So this phobia variable is kind of right there. We have 10 levels, but if you look at how many students had above 5, 6 and above. Well, if we look at our cumulative percentage, 87% of the sample were 5 and below. So only 13% of the sample was 6 and above. It could go either way. You could treat it ordinal, you could treat it continuous. People are going to argue both ways. Okay, so that's how to do our frequency tables. See how much code we have? Name the data set, type it in to furniture package. Function is table F, and then in the parentheses, say the name of the variable. That's all the coding you have to do. Okay, we're going to go on to plotting. Now, we are going to continue using the furniture package to make tables. We're going to make table 1s, which are descriptive tables, and table X, which are crosstabs and correlation tables, but the syntax is almost exactly the same. So once you have one of them down, you can do the other tables, and we will be using these tables for every single chapter. So pat on the back, you got another skill on your foundation. So now we're going to go to visualizations. Visualizations are going to take a little bit more typing, and they're a little bit more nuanced, but this is by far the most powerful thing that you are probably going to use in R, without some exceptions. R allows us to make visualizations that are powerful, beautiful, fairly good defaults, and quickly, very easily edit graphics that are quickly able to be in publication quality. And so I'm not going to go into all the details in this class about all the beautiful things you can do with Ggplot too. If you would like to learn, let me know. I can send you some resources. We can have a fun play date, but we're just going to do basics here. Okay. So the idea with Ggplot is the GG that's on the front of the name is for Grammar of Graphics. And this is goes back to the father of graphics to set out these kind of the framework for making good visualizations, especially with data. So the grammar of graphics. And the way that the grammar of graphic works is we layer components up to build our plot. Again, I used to teach in the dark ages before we had these computers with projectors in the classroom. So we had the projectors with the lights in them, you know, those boxes, maybe you've seen them in historical films, but we'd take clear pieces of plastic, overhead transparencies, and print them and put them on, and then we could draw on these transparencies, and the light would hit a mirror and project it up onto the blackboard, or a screen would pull down. And we can layer these transparencies, and the first one, and then one on top, and another one on top. And that's the idea we're going to use with Ggplot. Is first we're going to put what our X and Y axes are. That's called the aesthetics. Then we might layer some points, maybe some lines, maybe a smoother, maybe a different scale, maybe a legend. And we're going to layer these pieces up to make the full plot. And the layers, most of them are called geoms for geometric. And we're going to learn today how to do geom bar to make bar plots and geom histogram to make histograms. So geom is a geometric layer in our Ggplot. And before I show you the code, I need to give you an apology. Hadley Wickham has said, if I could go back in time, this is something I would change. So R is a package-based computer program. Anyone can make packages, and package maintainers can update them at any time. So Ggplot started as Ggplot without the 2 on the end of it, the original Ggplot. But that was before we had the pipe, and Ggplot, the original package, used something like the pipe, but it didn't exist anywhere else in R yet. So people had a hard time with it. So Hadley Wickham went back and revamped his package, and he used a plus symbol to add layers, adding layers with a plus symbol once you get into Ggplot. And he didn't want to break anyone's old code, so he called his new version Ggplot 2. So we are going to be using Ggplot 2. Ggplot, the original, is no longer maintained, but Hadley didn't want to override it in case anyone's old code used it. So that's why it's Ggplot 2, but the function name is just going to be Ggplot without the 2. I know that's confusing. And the other confusing thing is when we are doing our pipelines, we always add the pipe to link our steps. The pipe being the percentage greater than percentage set of symbols together. That's still true in the pipeline until we start making a Ggplot. After we start our Ggplot, the layers are added together. So with that warning, here's how you make a bar plot. You're always, like the frequency table, going to start with the name of your data set first. That's our object we're working on. So always start with the data set and pipe it. We're going to pipe it into Ggplot. And I also don't put Ggplot2 double colon in front because this is pretty much the only Ggplot that exists, and it is probably the most popular package in R at this point, other than base R. So the name of the data set, pipe into Ggplot. Now inside of the Ggplot parentheses, we have to do the aesthetics. And aesthetics are the axes. And they are labeled, the abbreviation for aesthetics is AES. And this comes from the olden days when we didn't have autocomplete. And so we wanted the names of everything to be really short so we didn't have to type a lot and have typos. So we're going to have to just kind of memorize how this goes. But again, we're going to be using Ggplot like this every chapter in this book, so you'll get lots of practice to memorize it. You'll memorize it before you even notice. So we're going to start with the data set, pipe it to link it in to Ggplot. And then inside of Ggplot's parentheses, we put AES for aesthetics and then the variable. So if I want to do a bar plot for the coffee variable, I put AES for aesthetics, and then inside the parentheses, coffee. Then now that I've started my Ggplot, I'm going to add the layer Bar. Now, when learning, I can guarantee you're going to get the two things confused. The pipe that you use before Ggplot and the plus after the Ggplot. It took me a couple of years, and I still will mess up and put a pipe when it should be a plus and a plus when it should be a pipe. If you do that, you will get a message, which is really helpful. It says, hey, by the way, maybe you meant to put a plus instead of the pipe or something like that. So it's pretty nice to remind you when you forget. So then we just add Bar. Now, Bar is for the layer of actually, if you leave that part off, if I was just to do data set piped into Ggplot aesthetics coffee, it would make the plot, but there wouldn't be any bars on it. It would still do the x-axis and the y-axis. To get the bars to be on top, I have to add Bar. Now, Bar is a function. Functions always have to have parentheses after the word, but these parentheses are blank. You have to have the parentheses open and close after the word Bar, but you don't have to put anything inside of it. And that will make the default bar plot. Let's try it for another variable. Now, this, I did the coffee variable, just plain coffee. And you notice at the axis, it has the numbers 0 and 1 represented as numeric values, 0.0 and 1.0. Well, that's okay, but if I was to use the coffee F variable, that's the factor version. So on the axis at the bottom, it actually puts the labels. Not a coffee drinker, regularly drinks coffee. Actual words instead of the numbers 0 and 1. Also, it only labels those two values. It doesn't put it on a continuum. So it's important to know if your variables are categorical or continuous, and to use the right version of the variable if you have both of them when you're making a plot so that it's labeled in a meaningful way. Okay. Here's major. So I'm saying data set, pipe it in to Ggplot with the aesthetic variable that we want on the axis to be major, adding bars. And now we have majors 1, 2, 3, 4, 5. Again, if I use the variable major, that was the numbers 1 through 5. Well, then I've got to always rack my brain. What was 1? What was 3? So instead of using major, I could use major F in my aesthetics, and now it will label the bars, and it might be hard to see on the recording, but it's labeled them psychology, pre-med, biology, sociology, economics, so that I don't have to remember in my brain a number 3 on major was biology. Now, here's an example of making the plot fancier. So this first part is exactly the same as the one on the previous slide, but I've added a lot of other elements, is what we call them, and layers. It's fun. I love it, but it's not necessarily, it's not required for this class. It's not necessary, but you can easily add other things like change the axis labels on the x-axis and y-axis, add a table, change the color, make them see-through, make it a black and white background instead of the gray background. Just an FYI. Okay, so we've done bar charts. Let's go to a histogram. Here's how we make a histogram. We always start with the data set, that object, and we pipe it into the function Ggplot. We want to plot this data set. Specifically, the aesthetic we want is phobia. And I can add Histogram instead of bar. Now, if you look at this histogram, you might be saying, are you sure, Sarah? Are you sure that's a histogram? Because I already told you bar plots have gaps, but histograms should be touching for the most part. And these are not touching. The reason they're not touching is because these bars are really skinny. And remember, phobia was a number between 0 and 10, but it was only whole numbers. So nobody was 1.3 or 1.5 or 1.7. By default, when you do histogram, it chooses how to make the bars, how wide to make them, how many to make. The defaults can be okay, but this is a case where the defaults are not okay. Those bars are so skinny, I want to widen them. So instead of having so many bars where half of them are empty, I want fewer bars. And the way you can do this, there's two different ways. One is to specify and tell the computer how many bars you want. And the way you do that is you say bins equal a number. Or you can say how wide you want those bars to be. And you say bin width equals a number. And you put that specific bins equal or bin width equals inside the parentheses of the geom histogram. When you leave those parentheses of geom histogram blank with nothing in there, it's going to take a stab in the dark and guess. But I can add inside the parentheses bins equal 8, and it will divide up that scale from 0 to 10 into 8 bars, 8 bins, and then it will remake the plot. Now, which one's better, which one's worse? It depends. 8 might not be appropriate because there's actually 11 values, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could make it a smaller number. We can make it a big number. So this is one of the problems with histograms is that this histogram with a lot of tiny bins, with most of them being empty, and this one with a medium amount of bins, all of them having some in them, to this one with very few bins being so wide, they give you a different feel for the data. You can have too few, and you can have too many, and you can have something that's just right. It's a good idea with histograms to do the default first and then try changing how many bins, how wide your bins are, to see if you get a better visualization. So here you can specify bins equal, and that's how many bins you want to cover. So if there's 1, 2, 3, 4 bins, or you can say, here's 10, I probably should do 11. And you can, the other thing is to do bin width. Now, this one was phobia. Now I've swapped out my variable to math quiz. So it's still the same thing. I start with the name of the data set. I pipe it in to the verb function Ggplot. And I've told it aesthetically I want my axis to be math quiz. Now, math quiz, it was a score between officially 0 and 50. I don't think anyone actually got 0. So instead of saying bins equal to say how many bins I want, you can say bin width equals 10. And so it will do 10 points wide on your bins. And you could change that to a smaller or bigger number. The nice thing about R is if you have a chunk that you've typed this code in, you push the play button, you look at the plot and say, I want to tinker with it. All you have to do is change the number 10 to the number 4 and push play again, and it will recreate the plot. And you can tinker with it till you get what you think is an appropriate number of bars and width of bars without hiding the data. The goal with plots is to not hide the data, is to reveal the data. Okay, so the last thing I'm going to show you with the Ggplots is how to add one more layer. Now, sometimes we want to look at a histogram for different groups. So I might want to look at, let's see, we're doing the math quiz, but I want to, so math quiz bin width 4. This is the same plot we have here on the right side, but I want to make one for the coffee drinkers and one for the not coffee drinkers. Now, this is a play data set, but you can think of in your own research, maybe you want to do it for the treatment group and the control group, maybe the typical developing and then autism. You might want to split out a histogram and make it separately for separate subgroups. You can do those subgroups side by side by adding a specification that you want to split on another categorical variable. In this case, it's coffee F. And the way you do that in R is you add another layer and you say Facet Grid. Facets are like the panels inside the plot. So we want to make facets or smaller plots in a grid fashion. Now you can do a whole grid Brady Bunch style of figures, and you can have one categorical variables for the rows and another one to split the columns. In this case, I just want coffee drinkers and non-coffee drinkers. If I want to make them side by side, remember the matrix dimensions were always number of rows and then number of columns. So the way what you put inside of the facet grid is you can have at most 2 variable names, and you separate them with the tilde wave. Now that tilde wave symbol, that's on your keyboard by the escape key in the upper left-hand corner. It's the one with the back tick on it. So inside the facet grid parentheses, you need to have a tilde wave. Now, if you put a variable name in front of it, it will stack the plots. If you put a variable name after, it will make them side by side. The key is you have to put a period where you don't have a variable name. So this code says, take the data clean data set and then flow into Ggplot, where the main axis, the aesthetic, is math quiz. Add a histogram layer where we're going to make histograms with bins 4 points wide. And then split it apart so that we have side by side based on the coffee F variable. And now we can compare the math quiz for the not coffee drinkers and the regular coffee drinkers. Now, this one on the left, the first one I used facet grid, I did a period, tilde, and then the coffee F variable came after the tilde. That puts them side by side. In this new one, I put the coffee variable in front of the tilde, so that period and the coffee switched. And now my histograms are stacked instead of being side by side. It changes the arrangement, whether you want to have them rows or columns. And sometimes one way's better or worse for your specific situation. But these are 2 different ways to use the facet grid to separate a histogram. Okay, last thing we need to learn to code. So today we've learned furniture table F, give it a variable name. We've learned Ggplot aesthetics variable, adding on either a GM bar or a GM histogram. And in the histogram, we can do changing the number of bins or the bin widths, and even fancy splitting or faceting by another categorical variable. So the last thing we are learning today is how to find percentiles, and these can be quartiles, quantiles, percentiles. So deciles are the first one we're going to do. Deciles break your data into 10% chunks. Deci is 10. So if we split it all into 10 chunks, they're 10%. 100 divided by 10 is 10% chunks. So the way you would do this, like all the code we've learned, we start with our data set and then we pipe it into something else. The first thing we have to pipe it into, because it's a 2-step process, we have to use the dplyr package to pull out one variable. So from the data set, we are going to pull out the stat quiz variable. So I want the deciles for the stat quiz that these students are taking. So I can know what's the lowest score, how the lowest 10%, how do they score, the lowest 20%, the 50, all the way up to 90%. So the way that you do that is dataset, dplyr pull out the variable you're concerned with, and then, I'm reading the pipe as and then, so state the dataset, and then pull out the stat quiz variable, and then ask for the quantiles. Quantiles is how you do all percentage breaks. And inside the quantile parentheses, you have to say manually what probabilities you want to break it at. And so to do deciles, you do 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and you could add 100%. But you need to do them as decimal numbers, as probabilities. So it'd be 0, 0.10, 0.20, 0.30, 0.40, 0.50, 0.50, 60, 70, 0.80, 0.90. And notice inside the parentheses, you separate those all with commas. And to put them together, you have to concatenate or combine that list of numbers. And the output, if you run that code, push the play button, you'll get a listing out. So the 0 percentile is 1. So that's the minimum. The 10th percentile is the number 4. So 10% of the students scored 4 or less. And we could say, what's the 90th percentile? That's 8.1. So 90% of the students scored 8.1 or less. Remember, percentiles are always the less than, the percent less than. So on your homework, you're asked to do deciles. You're also asked to do quartiles. Now, here's one hitch. Remember when I did the R chapter 1, so we did the mean function? If you had a missing value, that's with NA to fill in a blank value. If you had one value that was missing and you tried to do the average, freaks out and just gives you back a missing value. If I do the math quiz variable and ask for the same thing, so I've taken the exact same code but swapped out stat quiz with math quiz, I will get an error. And the error will tell me that NaNs are not allowed. NaNs are not a number. It's an abbreviation there. So what happened in this data set is that there are 100 students in this class. We know everyone's gender, we know everyone's major, we know everyone's stat quiz. That's the first stat quiz they took in the class. But this math quiz was like a pre-test to get into the class. Some people registered late or for whatever reason override, they didn't have it. So some of our students are missing the math quiz. So when we ask R to do the quantiles at some specific probabilities or percentiles, it freaks out if any of the math quizzes are missing. And that's the default behavior because we want to know that there are missing values. So notice the whole error. It says error in the quantile with these probabilities. And why is there an error? It says it's missing values or not NaNs are not allowed. If NARM is false, the default behavior of this quantile function from base R is to have removing missing values turned off. So the default is to not remove missing values. So if we want to do this ignoring the missing values, we need to change the default behavior and add an argument that says NARM, remember NA is blanks, RM is for remove, to true. So the way you do that is inside the parentheses after quantile, not only do we have to list the probabilities, but then we have to also put a comma and say NARM equals true. It says the NA blanks, remove them, you betcha. After you do that, then you will get all the 10 deciles outputted. I think math quiz is the only variable in this data set that has missing values. But it's good to know how to deal with them because I have never in my life had a real life data set that didn't have missing values. They all have missing values. Okay, let's do some other ones. Okay, so quartiles. Quartiles are very, very common. We're going to use them in chapter 3 a lot and chapter 4. Quartiles are when deciles are when we're breaking into 10% chunks. Quartiles are where we break into 25% chunks. So 4 quarters make $1 and a quarter is 25 cents. So the quartiles are 25% each and there are 4 chunks. You use the same code, starting with the data set, piping it in to dply or pull, pulling out the variable we want to do the quartiles for, and then piping it into quantile. The only difference is when we concatenate our probabilities, we want to do, instead of 0.10, 0.20, 0.30, 0.40, we want to do 0.25, 0.50, 0.75. And you can always do 0 and 1 on the either end. Now, when our output only has the quartiles. So the 50th quartile, 50th percentile, which is also known as the median, that's next chapter, or the second quartile value is 7. So half the students scored 7 and below, and then the other half must have scored more than 7. Min 0 percentile is the min, 100 percentile is the max. So we see the stat quiz scores went from 1 to 10, where half of them scored below 7 and the other half above 7. Now, we can do, in our probabilities, we can do nice every 10%. We can do every 25%. We can do any random percent we want. You just have to concatenate. So put the letter C, and then in parentheses, put any percentiles you want separated with commas. So I could do the first percentile, the 5th percentile, the 73rd, 17th.3 percentile, and the 90th percentile all at the same time. You can list as many as you want or as few as you want. And that's the end of the data visualization in our lecture. Now chapter 3, which we're going to get to next, will be center and spread. But now you're ready to start the homework and come to class, and we can have some discussions and work on some of these together. So thanks for sticking with me to the end.